Hello everyone. So today I'm starting recording a video chain. It will be a few parts about terrain, and I wanted to build a system where the NPC, non-player characters, will be able to actually manipulate and interact with the terrain, and the main goal is to actually to do this in the most efficient way, because what I saw in many forums and many people has raised the same questions about the performance and the splash maps or alpha maps, and including as well as detail maps. So the goal of this all tutorial, which will be a few chapters of course, it's actually when this dude will actually, at the moment we'll be controlling with the mouse, with the keyboard, will be actually passing the grass. It will leave a trail by just lowering that grass in that certain location where he's going. Another NPC will be choosing the same path. Using built-in Unity AI not mesh, we can actually set the cost of a certain terrain locations. So NPC should choose least costly and nearest path to his target. So then a second NPC will go or use the same the path, lower the grass even lowers more. In the script we'll be using the variable, and allows us actually to set how much of the grass we want to lower each time the NPC pass, and after the certain amount of time, which we can set in the script, we'll have a surface. And then in the surface, when NPCs keep still using the same path, we'll start painting another layers on the top. So I'll be using a different layer from a grass at the moment. It's still this one. I got a really nice package. I think it's called Azure Nature. At this video time, it's still discounted. It has all three layers I'm planning to use: grass, half grass with sand, and then fully sand. So there's three layers I'll be painting over. It won't be painted directly. It will be a smooth transition from one layer to another layer. So we'll decrease one layer to let's say the changes and the increments will be 10%. So we decrease 10% of one layer to 90%, and increase another layer from 0 to 10. So it will be approaching like every single time a person, just NPC, will be passing through, it will make a really nice trail. So here you can actually see my work environment is really simple. It's a small project. Well, not that small. It's an indie game. I'm working with my colleague, and at the moment I'm working exactly with the interaction with the terrain. It's a 2D. It's 2D orthographic view for game itself, and let me minimize that one. And it has already a few built-in functionalities, like etc. Mouse events on the top everywhere, and at bottom you can actually see it's built by myself for this events. The reason is because I don't want to use the cursor from Windows themselves, and the main reason is because this game could be published into Xbox or PlayStation, which doesn't have mouses, or you can't use DLLs for to change the mouse speed and so on and so on. Using a game object and game UI, you can actually create your own mouse, and you can control for just a PlayStation controller. It's not set yet how we approach this console games, but I'm planning in the future to actually release one of the videos where you can actually use your custom mouse and interact with Unity UIs. Another thing is, if you would like to see and demand, if is any demand about math.lerp, some people still struggling about math.lerp to use in some certain actions. This camera, zoom in, zoom out, is made with map.lib with nice timing. I can actually make few videos about that one. Just please leave a comment so I know how much, how big demand on that would be for that recording. So I have a small script just written, really quick one. I will show in a minute. It just allow me to actually walk with that dude in the map and paint some terrain. For some reason I decided to start from terrain itself, because it's laid down all the basics we need for the grass. Details. Let's call this not a grass. Let's call it detail, because it could be grass, it could be anything else. And yes, one of the main things is, yeah, you can see it's not interacting, nothing. So so let's start from a terrain, and then we get for a better understanding about painting terrain. We can actually get from painting terrain to the details terrain. Cool. So yeah, if by the way, if a bit talking a bit more about game itself, I think in the second video maybe I'll prepare a bit more detail, like a small story maybe what we actually building in this village, and nice environment. So let's start with as I mentioned it, about a control object script. By the way, in the second screen, guys, you can't see this one, but I'm actually using a profiler. I actually should stop recording. I'll keep bringing this profiler on the screen sometimes to showcase actually performance, or in milliseconds, or as you can talk in the frames if you want to do math. But we can actually see the performance, and we can actually start comparing it, and you get idea where we are at using this approach of interaction with terrain. One of the things I would advise is actually to have a good to look in the tutorials and get some understanding what you're seeing in this this profiler. Myself, I'm just actually trying to narrowing where all the latest is coming, and if it's not my scripts, is only the Google and search can help me with a Unity something approach or settings. But main thing what I'm trying to achieve is actually to make sure my script is not leaking some garbage, is not taking too much time to execute, and I write them in high performance code. Okay, so this is really straightforward. We have a left and a right arrow. I'm using actually, by the way, a new input system alongside an old input system. Which one is here? But so left arrow and right arrow are taking a local rotation, and in quotations you're not adding, you're multiplying by quotation dot euro, and we're taking up axis, so the person will be rotating around his y axis. We're taking a public variable speed. We multiply by 50. I found this is a really good point in compared with the speed of walking. And of course we're multiplying by time dot delta time. Time delta time is one of the key features you as a indie game developers or any developers, if you're doing any actions or calculations of anything what's moving in the scene, you need to use time delta time. Time delta time is a fraction how long took the last frame to render. This multiplication by time delta time would put how do you explain in correct way? It will make equal amount how much this NPC will rotate in, and not care about how many FPS it pass. Oh my gosh, that was long, hard sentence. Let's do one more time with the painting. So if we write a code that per NPC or any object, and any object, yes, must go at speed 50, yes, and this computer runs at 60 nice frames. So code will run 6 times per second, and in 1 second he will go 50 times 60, because 60 frames, he will go 100 meters. Well, but we said we want 50 speed, which one would make sense, 50 meters per second, not 300. And where is the flaw on this approach? The flaw is if someone else who have a wooden computer runs at, let's say, 25 FPS, close to my wooden computer, so he only will do, in 1 second, he will do only 25 frames. So each time he goes, if we set as well 50 speed of 50, their code will execute only 25 times per second, which one makes, who can do the math, it's 125 ish. That's, oh yeah, that's 3,000, and that's 1,000 something like this meters. I'm correct? 0, 5, yeah, I'm assuming you get idea. I'm recording this first time. It's not, my brain is not actually focused on the math at the moment. So two computers running the same game, and this approach will, depending on FPS, which one is not reliable, depending on the computer's performance or the code you write down, it could be even faster or it could be slower. You always get a different experience per user. But how we can actually to make them equal? That exactly, it's multiplying by time delta time. Oh, my writing is terrible. Delta time. You get idea. So time delta time. So doesn't matter how much FPS your computer runs, both players will in 1 second will run same distance, because this number, time delta time, is the time of frame. In 60 FPS is 0.16. So whatever distance you're getting, you're multiplying by 0.16, which one is smaller number compared with 25. 25, if I think, let's say 30. I know, but 30 FPS is exactly, where's my mouse, is exactly 33 milliseconds. So, oh, yep, my bad. Yeah, so 0.033. So you're multiplying this number by this. That multiplying by a smaller decimal point makes this increments even, where's my mouse gone? Okay, this makes even smaller increments to reach this point, and here he makes larger inputs because it's multiplying by large, and in 1 second both computers will reach the same point. So this is the time dot delta time in a nutshell. So that's why we're using this one. I'll pause this one if you need to copy paste. This is the same approach for forward and forward and backward code. Yeah, going forward. So that's how we apply to allow this dude to actually just to walk around, and only this is only just for a keyboard. Actually, this is only for testing. Let's put it this way. So first of all, we will need a terrain script, and actually I have already started yesterday, but I decided to actually share this knowledge with the world. So I have a terrain painter, but I wanted to rename it something else, and terrain painter 2, and I want a terrain interactor 2, so I can actually start from scratch with you guys, and you can actually follow everything from beginning. Just I need to rename the classes I have created differently. Save, and we have this one. Patience, guys, patience. Yes, patience. Patience is the best. I think patience is the best thing. Did you believe that one? Okay, I have so many classes now getting off the naming. And what's wrong with you? Okay, train print because I can. Why you can't? Should can. Terrain painter request is not. Oh, okay. Got it. Yes, got it. Okay. How about now? Are you okay now? Sorry guys about this one. So because I created a number of classes, changing this one's this files folders in different name actually cause a bit more hustle than I expected. So let's create a new script. Terrain painter. I call it painter, even though we will be interacting with the grass height as well, with detail, but it still will be as like painting a lower grass. You'll get in alongside. Just come along with me, and you'll understand later. So terrain painter, and we'll come later with terrain interactor. Cool. So, is it possible we can actually get this one out? Nice. Okay. Do I want like this? Nah, I don't wanna. So a terrain painter we get here, and we get terrain painter 2 here as a note for me. Cool. So, one of the things what we need is actually a public variable for terrain, and that will be terrain on which the NPC is standing on. One of the things is that if you look in our game, yes, you will be seeing that we have quite a bit of terrain. By the way, I'll show in a second. Just can scrolling is faster this time. So if we go in environment and we have terrains, and voila, so here is all terrains. The terrains are actually 100 by 100 100 by 100 size, and I think it's 7 by 7. Yes, I think it's 7 by 7 terrains in the middle of the map. Which one will be a main terrain zone to? It will be a main terrain zone where all the game will be happening, and we have a terrain as a border. We'll put the mountains here. My team member, a colleague, he is working on it exactly at the moment now. So in the future videos, so maybe you will see some progress on that one. Depends how busy in real life we're getting in. So here is, by the way, if I can go, it's a small lake. It's not finished. I actually got a bit better. We have like what's called? How they called it? Lilies. I don't know why it's lilies. So we have a lilies, we have using a shader actually to move them, and we have some stones. From low poly we get to 1 level up. Let's call this. We have some fascias. They are actually moving. Is it? Oh no, its game is not played, so yeah, it's a shader moving them. But when you play the game, is a script which one actually circle them around. We have some nice what's called a bridge. We have a dude here. We have some buildings. Which one? It will be a certain location to allow the person to actually build. Water has like some things as well. I don't know how to call this one. Foam. Yes, that's the one. A foam on the top. I'm actually not most happiest person with this water. We have some few water example shaders coming in Azure Nature Pack I mentioned before. So stay tuned. You will see soon much better lake. So environment and yeah. So coming back, we have quite. Where are you? Okay. So we have quite a lot of terrains. So in a script at the moment, we are not grabbing main terrain because you can actually grab one only terrain, which one could cover a whole map, and just work with that one. The issues is with this one that when you do updates in some terrain locations where the NPC is interacting, it's better if you actually interacting with a certain location of terrain, much smaller scale than 7 by 7. That means a terrain would be 700 by 700 instead 100 by 100. Even though, let's say the game expands so much and action will be occurring in each terrain at the same time, and all the terrains, that leads exactly to the same issue where you will be interacting with the whole terrain. But up to that point, you'll be only interacting with one terrain at one time. And this is a good note, by the way, for myself. To do. Yeah, this is a really good chat, by the way. To do, check performance if need to interact with all terrains, with all terrain. Yeah, terrains. Leave it this one. And I want to leave one more to do as well. So at the moment you can see is only single terrain, where I'm planning to actually do later as array. So depending where NPC is coming from, we'll know which one terrain he is on. And this is even leads to why I'm not doing from beginning, because I don't want guys you confused. Because the issue where it will be difficult is actually when NPC is actually going from one terrain to another terrain, and the painting request, because it will be few some area around, you need to actually the half area he's stepping on to transfer to another terrain, and that calculation must be done in alpha map calculation. So I don't want guys to confuse you from beginning, so I'll leave it this one a bit later. So let's make a note. Let's make a note here as well. To do is really good note keywords where I left it to myself. Come back here, check what you need to do. It's not note what you have done here. It's note don't forget to something to do. So later on you can actually go Control F, and you can actually say okay, entire solution, and you're saying to do. Enter, and you can find one to do, another to do, and that's it. Is no to do, no more. So you can actually look for all the scripts you have written in this solution, Unity solution, and you can actually find all to do you left to yourself. Do not forget to do it. So this is really good, nice tip. I don't know where I get this one, by the way. So I'm not claiming I thought about this one. I just read somewhere or someone was doing this. So claiming as the owner of this idea. So to do create array of all terrains to find out which terrain NPC is on. Okay, so we have a terrain, and now we will be using another variable, vector2 int. Vector2 and vector2 int is only one different. It can't hold the float numbers. We'll be working with integers only. So instead of vector2, we'll be using vector2 int, and we call it a map. It stands for alpha map, and of course we can do a map position. So why integers? Alpha map is actually a picture, and the picture has well, I don't know. I open this one. Close. Oh. Where are you? Yeah. So if you imagine any picture, picture is made from pixels, and a map position, we will get any location of a pixel. So a location of a pixel starts, by the way, from 0, and I think it starts from this corner, by the way. Anyways, it's 0, and let's assume it's 2 from the bottom. Yeah, this one. Yeah, if counting from this corner. So what I'm trying to say, oh yeah, splash map in Unity. Yes, alpha map is matched, by the way, Unity coordination. So it will be 2, 0. So coordination of this pixel, it's 0, 2. And if you already got it, yes, you cannot have a half pixel coordination. It's a pixels, so it's only integers, not a float. You can't have information what color of a pixel is, a half pixel of this and half another one, because that doesn't work. If you wanted to find out what color pixel is, you need to decide, you want this or you want this. You can't just have half and half. You can't retrieve. So that's why we are using at the moment a vector2 int alpha map position. Okay, last of the main variables, I just like to keep everything tight, is actually list of it will be of a class. We don't have a class created yet, and I wanted to just leave it empty, maybe. Yeah. And you know what? Let's create class first, and we come back here to the list. So yeah, how I was thinking about this one. So we can actually do here once, and you will get why I need a class instead of vector2 and int and terrain painter q. So terrain painter q is equal to new list. So new list will be creating this list inside in the memory. So you can imagine as you activating a list to be able to use it. It clears location that memory, so you won't find any garbage and other things. So here's a problem. Well, I found this problem later. So here we have happy days, we have pixels, and we're doing some cool stuff. And let's say the NPC is walking, and he just walk here. We paint red, and he walks here, and we paint red. And he walks. Let's say he walks here. we imagining that our NPC is a pixel size, I don't know, ant. Can imagine this one. So he walks here and we're painting. The problem is that if maybe it's not NPC, maybe it's something else. Maybe it's a carriage with a horse, or maybe it's something more heavier, heavier. It's a person, maybe with I don't know, maybe with some stone in the hands. We want to put the grass even lower, or if it's a bigger size, we want to actually paint slightly here, you know. Well, you can't paint just half pixel, as I mentioned before, but imagine like it's 1,000 small pixels here, so we can actually fade off really nice, how to say, fade off this paint. So when the person steps in, he paints like a really he interacts with the terrain in the middle a lot, and it fades off in the sides, so this makes a bit more realistic experience for a player. So we have this one. So we have the coordinations, we have a fade, we have a zone. We maybe want to interact with how much it's actually, how to say, how much it actually interacts with the grass. If it's just a kid running, do you wanna just lower the grass a bit? If it's like a big massive guy is walking with carrying some heavy I don't know, bag, and you wanted to step the grass straight away, or I don't know, maybe you are building a road in that path, and so a guy's coming with a shovel, and you just wanted to destroy that grass after free shuffle, you know, shuffling, whatever it's in English called. So yeah, we have a certain amount of variables. So we have few options. Let's say we have this list of buckets. Terrain painter request. So if we drop in grass, green, it will be position. We drop how much it must interact. We drop I don't know, fade amount, how much it must fade, and of course we need a blue for a size, how much of terrain it must to interact. After we keep throwing it and we keep removing it from a list, and it will be using, by the way, if someone is interested, FIFO for this one. I'll talk about this one later, but this is really good to know, FIFO and LIFO. Pause the video, do really quick, shortest video you can find in YouTube. It should take 1 minute video with a nice explanation. I'm definitely not the best person to explain this one because it should be animated to get full understanding. So anyways, coming back to this bucket, the problem is that you start throwing all the bits in a bucket, and to better understand, I will put this way. We have now a bucket, a list of position. Now we need another bucket for how much it must interact with the grass or terrain, so amount of painting. Then we have another bucket, and bucket is like a list of a queue. So we'll throw another one. It's not size. Well, how much you say? Oh, fade amount. And the last one, it's another bucket for blue color. It will be how the size of the paint you wanted to interact. And now we keep throwing more in the queue because we have lots of NPCs, and we keep throwing that ones, and we actually really relying on a code to pick up the same item all the time in pairs from a bucket. Why we accidentally, not accidentally, or by mistakenly, when we rewriting up something, we can actually pick up this green and a wrong how to say, wrong interaction and variables. So we will be pulling out different sets of data, and if you missed one, all the rest data in the bucket will be wrongly, like, how to say, paired. And it's really easy to do. One null reference in that frame, when you need to remove from a bucket something, and it will get null references, be reason X or reason Y, and that's it. Your queue is messed up. Another thing is that you'll be creating 4 different lists. In memory-ish same, but for all the actions we'll be doing later, it will be performance consuming actions. Not that much not big consuming, because it's not the largest game in the world, but you know, small bits add up and you'll lose some performance. So instead of that one, we'll using only one bucket, one list, and we will create, instead of each different colors, we will create a class of one big ball, which one holds our position, our interaction, our size, and our fade. And we create in one bubble. Great thing is in this class, because we can actually create some functions inside. We can add later on, if we want, we need to just add more variables or more calculations, or even some questions we want to, like, how are you which terrain you are, and we can actually do some function inside which one takes like position and returns an ID of terrain, etc, etc. So this is really great. So we can keep holding everything in one class, all the small variables, and we throw whole class as a one item in a bucket. So this is what I'm trying to achieve. And now we have, as I showed you before, it's a green color, that bubble, it's just position. So what we do is we create a class, and a class, the coolest name I thought is yes, it's terrain paint requester, or just requester. Oh my gosh, Chinese keyboard. Public terrain. Oh, sorry. Oh, my bad. So class. Oh my days. I said class lower C, not capital C. So terrain painter request. It's a class, so we don't need this one. Ba-bam. So and as I mentioned before, we should have a public variables because we want to access them. And we'll be having a vector3, so position, pose, so where in what location this terrain request is coming from. Then we want to public to have an integer of paint size. Should be integer, because this paint size will be applying for alpha map, which one, as I mentioned before, is pixels in a image, so it can't be a floats. Then we have the same applies to fade size as well. And last but not least, we have a public float, and we have paint strength, paint strength. Oh my gosh, why are you doing this to me? So paint strength. So here is our class, which will hold all these functions. We will be adding more stuff. One thing at the moment, sorry. Okay, so here we're creating this bucket of a list, and we actually want to create of this list. So type of this. Boom. terrain Q. Nice and easy. Now, can imagine we are creating one of them. So first of all, easiest way what I find to explaining about classes when the people is creating them, they a bit getting mixed up with the functions. And the easiest way that I found to explain it is actually imagining class as a variable type. An easiest way to take and compare but what is everyone most familiar with is integer. So what we're doing with the integer, we're saying variable type, it's int. Then we give a reference, a name for that, x. That's it. We just create a variable type. Oh, sorry, we create a variable x, which one is type of int. A type of int holds the, don't even ask. It's a number. It's numbers without decimal point. Let's put it this way. So it holds this all this variable types. So for a class, it's really same procedure. What we're saying is we first of all defining the type, and the type of variable is terrain. Oh my gosh, I need to paint terrain. Paint request. Here are you. So we just describe it a variable type. Now we give a name. Let's say paint, etc. And that's it. That's how we use the classes. You give a variable. You give a variable type and you give a name it. And the beauty of that one is that we can create another one. Jesus Christ, I'm already tired to type in paint. I need a better naming. So yeah, now we have two terrain painter requests variables, and each of them holds all this. So in update, let's say paint. I want to say paint dot pos. Oh my gosh, what the hell? Paint. Oh, I can use here. Sorry, because I created in this code block. So when you're creating variable in a code block between curly brackets, I think it's called curly brackets. Sorry if I'm mistaken. So when you're creating variable in curly brackets, it's called a code block. That variable only exists in that code block. So that means paint here it's not found. It's just paint doesn't exist in this current context. And same exists for if you say x is equal and yep, and then it's like wow, you don't have x. That's why when you're creating variable between this two curly brackets here, sorry, this is class. So between this and this, so this variable a map pos exists inside here, and everywhere here, but it doesn't exist here. Because this is a last curly bracket he was created in, and that's his existence only scope of this variable. So I can't show here, but I will try to show here. So paint dot pos is equal to paint to dot, I don't know, paint size. Yeah, you see how I can actually do this one. Of course they're giving me error because first of all you can't convert from pos to this one, and this will give you unsigned because we never do this new, but I don't want it to go forward too much, but you get idea. So you can create a multiple classes, many classes. We're giving different names, and they are two different instantiations of this class. And each instantiation will have own position, own paint size and fade size, not equal to another one, to another instantiation of the same class. So this becomes like a stamp. When kids are having like what's called like in sandbox we're playing with buckets, and we fill with sand, and we just flipped over when we have like a stamp of a like a sand bucket wherever, and it's like a small castle. So it's happening here similar. So here's our buckets, and we keep stamping them, and we can have a multiple of them wherever we want. So this is like copy paste thing. So going back, the thing is, if we want to create one of them, we're saying a new terrain per request. So what it does, it's the compiler X, you done your job, you was a wonderful variable, now you need to go on. Okay, so what the compiler will do, we said this is a type of variable, we give a reference for human understanding, because this reference is actually in compiling time is gone, computer using a different approach, and but for us to better understand code, it's a reference what we can understand. It's a paint. I think this reference is transferred to a hexadecimal location into the RAM. Leave it a comment if someone can actually explain a bit more. I can't exactly remember, but I believe the reference is actually converting into the locations into RAM, and we by this paint, which one is readable for us for computer is I don't know, AAA0XD whatever. It's address in the memory where this variable is located, and type is actually telling how many bits you need to read from that location forward for gathering the data, and in what format you need to read it. Like if it's float, you need to read the 4 bytes and so on. So I'm going too deep. Anyways, coming back. So here we created the paint. Now what we need to do is saying, okay, paint must be a new vector3 which one the position will be, I don't know, 100, 110, 10, 10, whatever. I'm doing this really fast because this doesn't vector2 paint request. Oh, sorry, paint pause. Yeah, position is this one. Then we're saying, okay, paint size is, I don't know, 5, and paint dot fade size is equal 5 as well. I'm just making any numbers now, and you get idea. So it's a pain in the ass. We created a variable. Now we're using another 4 free lines, and just actually explaining, not explaining, but trying to set up this variable. And after that one, what we do is terrain painter queue. We just add in that bucket, and we pass a reference in the memory of paint. Don't forget, as I mentioned before, the paint was created here in this scope. That means after the scope here, the paint doesn't exist anymore. If we write paint, it will be giving error. The paint doesn't exist in this current context. Only one way to can actually achieve this one is terrain painter queue, and we pass in index of 0. 0 is the first member in the queue. So yeah, now we can say pause, etc. So because this paint went in the queue, in the terrain queue, in the bucket first, we can actually access. Now we don't access as a name paint, because this will be deleted by garbage collector, and only how we can access now, it's by indicating which one member from a bucket we want to access, and because we have only one, it's a 0. If we try to do this one, it will be error because we don't have a second item in the queue, in a bucket. But still, as I was saying here, it's a pain in the ass to do this one, and this will be even harder later on to do all the stuff like that for a single item. And thank goodness we have a bit more advanced tool inside the class. We have, it's called Constructor. Constructor. Yeah, sorry for my spelling. So we have a constructor, and we can actually use that one to help us with this in this situation. By default, so constructor is a function which one we no need to give void or anything else, so it won't be returning anything. And normally, if a function doesn't return anything, we put a void in the front. With the constructors, we don't do that one. We actually don't actually do anything. We just have a special sign for deconstructor, but for a constructor we don't do nothing. One of the key points, what it must be, it must match the class name. This function must be named the same as a class. So, and same, you do brackets and you do curly braces. And here you just overwritten default constructor. This is created by default in C#, and here you can see. When you create a variable type as a class, you give a reference paint. Now you construct it in memory. So you're saying new, and you call this constructor. Constructor is a function which one is named the same as a class itself. And by default, you no need to write this one. Back to old days, I believe C++ 8th generation. Oh, I can't remember exactly. It was one of the, I think it was one of the requirements. Maybe I'm dreaming something, but it doesn't matter. Coming back. So, yes, you no need to write that one because by default it's empty, just constructor. But we can actually create ourselves constructor. So the great thing of a constructor is that it can actually take the variables as parameter. And when we're creating a new paint request, we can actually pass here all the numbers. So in our case would be something like, I don't know, something like 10, 5, 5, etc. And this variables will be transferred as all this one inside in class, and we no need to do this one. Doesn't looks better? Yes, it did. I know what you're thinking. It's I'm getting lazy and you can type this one now. One of the greatest skill of the coder is be lazy and create functions which one actually make life much easier. And if talking seriously, one of the key points is actually as well to make code more readable. Less lines, less confusion, and less executions you need to read. You can actually better understand the code yourself, and when it grow up to thousands, 10,000 lines, you'll see how this really helps you if you start doing this way from beginning. Anyway, coming back, so we want a vector3 pos. So do not confuse with pos here and pos here in the parameters. Sometimes the people are confusing, and sometimes myself I'm not sure which one compiler is taking on, because later on you're saying like pos is equal pos. Okay, which one? You know what I mean? So yeah. So what I'm find easiest way to do, I just give this underscore in explanation. Now we need integer for paint size, underscore paint size. Then we need, sorry, comma. Then we need integer for underscore fade size. And the last but not least, we need a float, oh, sorry, float, and then underscore, it's a paint paint strength. Okay. Yeah, spelled correct. So what we do now is local post. Oh, by the way, yes. If someone was about this one is which one? Yes, you can save your time. Don't put a comment about. You can do this dot post equal post. So this dot variable name actually states that you using the variable, which one is local, which one is in this scope where you're putting this. So in our case should to be like, yeah, something like that if you're using this without post. So yeah, I just don't do that one. Sorry, my OCD is like kicking my head now. Don't do that one. Do what you know. So I take it when we call this constructor in a time when we creating this variable, we take all these parameters in here. We'll take all the parameters and we save locally in this class, accessible publicly. So that means later on we can actually access this paint, access the paint class variables inside which one we're saving in the creation time. If that makes sense. Paint size and fade size is equal fade size, and the last paint strength is equal to paint strength. Nice. So what we can do now, we can actually say, okay, we need to pass vector3. So we can do straight away inside here vector3 of 10.10.10. Now we put comma, and we can actually see every single time you put a comma, one of the parameters you need to enter gets bold. So I can see now I need the paint size. So let's say 5, and you look here, when I put the comma, it will fade another one, comma, you see? Fade size, 5, comma, paint strength, 10. And it's really important to give a correct, good naming, because when you call this, you know what each number will mean. If you call A, B, C, when you give a numbers, it's like, okay, what is this C? And you go back, oh, C is like fade size. Okay, that doesn't make any sense. So that's why you do this one. Nice. So we create the paint, we just pass all the numbers, what we need, and looks doobly-dibbly. Now, how it would be great if we know that interaction with the terrain will be happening mostly by non-player characters, so NPC. It would be great if we just skip all this, variables, and we just take the position, and all other ones would be set as default ones. And if something else happening, like a horse carriage or something like this, then we can add all these numbers. So is a way how to do that one. So every single time parameters you enter in parameters, yeah, you can actually give them a default values. So allowing us in code later to actually do not pass them. So in our case, if we want to give it a default value, just say here equal 5, etc. So have a look in notes what we need to 5 or 0 5. So we give a 5, and paint strength we give a 0.05 float. Yeah, so this is the default values, and now because the position is a critical one, you don't want to give any default ones. It doesn't work that way. So why are we still having here? Okay, I want to make sure we're recording quite good. Okay, yeah, following steps, what we create. Okay, so the position is critical one, so we definitely want to take positions, but you see it's no more error because compiler, okay, you're not giving me a paint size, but I know default is 5, I know it's 5, this one is this one. So now we just create we're saying the variable type, we give a reference, we construct it in the memory, and we passing this value. And that's it. Everything is creating in nicely in the hold on, yeah, in the memory, in one line. Really nice, straightforward. What we do next? We just delete this one, and we delete this one. So what we actually want to do is inside, well, this class, leave it in a bag. Leave it somewhere else. Don't get mixed up with the class. Let's come back to Terrain Painter. Terrain Painter is using this class as a variable here. That's it. Leave it in the end. So let's go back to Terrain Painter. By the way, which one is inherited from mono behavior? This doesn't. So this won't have. It should not have like game objects. It does. Huh. Neat. I can't remember exactly what's the difference, but yeah, it's because it's not inherit. Oh, because it's not inherit from mono behavior, you can actually attach this one to game object. You can have a game object or a variable, but you can attach. It's maybe too complicated to understand, but it is different from terrain request, which one is not inherit from mono behavior, and this class, which one is inherit from mono behavior. Mono behavior class is from Unity. So that's why we can actually terrain painter attach to game object. If we're coming back to this dude, second. Yeah, if someone is interested, by the way, why I'm moving so like I can move and spin around like that. It's a 3D space mouse I'm using. It's a package that's coming from what's called asset store. What is over? Yeah, Space Navigator. So it's coming from here. Plugin, and I have just space mouse, which one is mega helpful in Unity to create all the stuff, and you can actually fly around, and it takes like 2 hours to get used to, but later on, I'm really highly advise you to have one of them. So let's carry on. What are we at? Oh yeah, so here we have a dud, and here we have our scripts, environment, and terrain painter. And because terrain painter class is inherit from mono behavior, I can actually do it like this, and I can see the terrain painter script, which one is a class with all the variables we do, and so on and so on. But we can't see the terrain painter class request class because it's not inherit from mono behavior. If that makes sense. Cool stuff. Let's carry on. What next? Yeah, inside in this class, which one is from mono behavior, we want to create another class, public, and it will be won't return anything. This class won't return any results. Let's put this one more explaining. The function won't return any outputs, no results at all. So that's why it's void. Public, because we'll be accessing it from outside this class, from another class. And the function name is add terrain paint request. Add terrain paint request. And what we need to do is actually really similar what we've done here. Can I copy this one, please? Thank you. Paste. Boom. Boom, chicka, boom. So we will call this function, and we will pass all these numbers as parameters, as well, again, as we can pass as defaults. And what we're doing is we are actually creating, let's do this one, paint request, painter queue request, terrain paint request. Yes. And obtain paint request TPR is equal new obtain paint request, and we pass this one. Pos paint size, fade size, paint strength. Okay, I'm doing a long way now, but I will short it in a second. And so what we done is we were saying the variable type, we gave a reference, and we creating in the memory with passing the position, paint size, fade size, and paint strength. So this function in later will be called from every single NPC. So NPC says like, oh, I got a certain distance, which one will be set in over there in NPC scripts. So he walks a certain distance and he says like, okay, this is my new location. Please paint this terrain in this location, so this position. Please paint this size with this fade in the sides, and the strength of the painting should be 0.5, etc. So what we do is we're taking this request, we're creating with this all parameters, saving inside in TPR, so we can actually say TPR dot position, and we get this position of this request. But because we will be doing, we need to throw in a bucket, and we will deal with the buckets later for performance reasons. So what we're doing is we have terrain request. Oh my days! Terrain paint cube. That's one. Terrain painter cube. Why is it paint? Okay, we need to rename it. So terrain paint request queue. Let's push this one. So request terrain request queue. And now when I change the variable name, always you can press that moment when you just finishing edited. Don't click nowhere else. You need to press Control and dot. Opens this menu, and you just first option is rename terrain painter queue to new. So you make a changes. So please rename all the variables which one was linked to this reference. So I press this one and it's changed here. Boom. So sometimes you're changing something, it will take time until you get all the variables in the long code. So what you can do, just control dot first option, boom, you here. So what are we doing next is okay, sorry. So dot add TPR. So yeah, let's have me a water. Okay, so what do we have here? Someone who already followed a bit and haven't got sleepy yet. I mentioned about creating a variable inside in a code block. This function is fully done. That's it. We just receive a request to add request. We create this function, we create this variable, and we add it into our bucket. But we create TPR as a reference to this memory, which one will be deleted after this curly braces. So literally straight away after he was created, he will be killed. So really short life of this variable, we could say that way. The problem is that builds a small amount of garbage, because TPR references, we don't using TPR reference anymore to that location of the memory. We still have this location, or we still have reference to this location via terrain request queue, and it will be first member. So by index 0, we have access to this location, but we don't using TPR anymore location. This variable name is forgotten, and garbage collector is and C# is kicking at a certain times. It's Unities keep changing and developing quite. They put a lot of attention to this area. 2020, I think Unity has some improvements to that one, but let's get coming back to out of that all news about Unity. So garbage collector will need to remove this one from like any memory because we created and so on. So what we can do is, if we're not doing anything with this class, instead of giving a name, let's create a class inside here. So instead of we creating and giving name and then we passing the name in to add to the bucket, we creating inside this function, and what is created passed to the bucket. So maybe it's a long line, but it's efficient, a bit more efficient. I can't tell you exactly how much, but small bits like this add up. Cool. What next in our list? So we have a function. We have a function. We have a class. We don't have anything here. Okay, so here we do a new one more thing. It's called a region. So region was called C sharp, and this is hashtag. Yeah, hashtag. Okay, let's call it hashtag. So we have a region, and we can create a hashtag, and I said and region. So the cool thing is that we can actually put as many things as we want here, and we can actually collapse. Oh yeah, don't forget about we can give a name for region as well. So it's nice readable. So region is, I call a functions. Oh, I can't give you good names. What the hell is going on today? Variables for functions. So the reason I want to collapse is just it's just placeholders for functions. So if you're running a function, let's say in the worst kind of scenario, you're running a update. Yeah, that's about. So int is equal, I don't know, is equal x, int x equal whatever, y, whatever. Jesus Christ, I don't know. Yeah, yield instructions. You can call it like that one. So what I'm trying to say is, every frame you creating new x. Okay, that's maybe what you want. You know, but you need to use that x in multiple locations. So maybe you need to use somewhere here, and maybe later on you need to use here and here and here. So that's why you need do one calculations on the top and reuse multiple times inside in this update function. Update function will be running every frame. So the problem is that every frame you'll be creating new x in different locations, and the garbage collector must go follow you and keep deleting the old x's you're creating every frame. And no, it won't be created in the same location. The garbage collector must actually confirm that the reference of the previous x is lost, so it's no more any variable referencing to that location, and that x could be and that x can be deleted. That's exactly what the garbage collector does. So don't do that one. Instead of that one, just create int x here. Do your calculations every frame in the same locations. Reuse multiple times in the frame, and use the same memory location. And do again next frame. Do again your calculations and reuse again in your code. And you keep looping every frame. So we'll be using the same placeholder in the memory for your calculations. That's again a bit efficient. And I'm repeating myself. Small bits add up. So, but what from many coding years, what I found it is, I sounded like an old person now, just many coding years. No, okay, let's forget this one. So, what I found it is that putting variables like such as this ones, which one you're just using as a placeholder for functions, it's just putting in some region. You see, when you collapse variables for functions and you're opening, blah, and you have all of them, and you can close it. It's really nice to just, you know, to be tight in your code and efficient, especially as me when I had like some OCD problems. So we'll be using some codes here. I don't want to start filling them yet, because if I throw 5, 10, 20 codes now here, we'll be like, what the hell are you doing here? So in update, we actually do one thing. So if terrain request queue dot length, oh sorry, count, yeah, count is greater than 0. So if we have anything in our bucket, throw in. So we have one request, we need to do something, and this is what I came up best solution so far. So we don't want to repaint terrain multiple times the same frame. We can paint 60 new locations per second and not lose any performance. And if we start painting at least twice per frame, it's actually starting fills up. So that's one thing. Why once? Because it takes about 10 milliseconds, and using what called which one I want to come later. It's using another thread for this. It's actually doesn't take longer than 60 FPS. So it won't be bottlenecking. So what we want to do is actually just do one paint per frame. So if we have at least one terrain in that one, we will be executing him. Execute here a first object with a first request. Yes, execute here a first request. We don't have a function yet to do that one. And what we want to do is actually terrain request queue dot remove at, and we give a 0. So what we're doing here is actually, okay, we're done with the first object, let's remove it. The list is really great because when we're removing that one, so the second item in the bucket becomes first, and so on and so on. So we like all the line is like sliding in. It's in a nutshell. I don't want it to be over complicated about links in the memory and why list is so dynamical expanding in memory compared with arrays. But this is a great thing because we remove the first one and we're taking this one. And yes, who's already typing the comment about I should use the stacks. I'm more confident using lists instead of a stack, so I keep my guns, which one I'm comfortable with. So execute here the first request. Let's do this one. I think it's taking quite a bit of time already. So okay, let's do a small pause here, and I want to check, is this recording correctly? It's the first time I'm recording, so I do apologize about quality of sound. I'm not used to this equipment yet, and I'll back in a second. For you guys it will be second, for me it will be like maybe it will be next day. Ta-ra. decided to actually carry on today's video, so I wanted to actually start uploading and editing tomorrow. So I want to actually to finish at least this script, because I just seen it's 1 hour 20 already. I get it a bit longer than I expected, let's put it this way. So let's speed up a bit. Leave it in comments below. Is this pace so far was good? Do you like this in detail explanation, some certain aspects of the code, or aspects in C# or Unity, like behind the engine? How in depth I should to explain it, because I don't know exactly what kind of people will be coming here to watch this one. It will be beginners and we want a bit more in detail, or it will be more advanced and just want a brief, really quick explanation. I'm trying to find this middle goal. So first of all, one of the key points what we need to understand is about conversion from where we standing in 1 second. Yes, I do apologize about microphone getting a bit too loud in the beginning. So we need to understand when NPC stands somewhere on terrain, we need to transfer that in a into the alpha map image. So if you imagine in here, we actually standing with NPC here. So NPC has his world locations, and if you move around, we can see X and Z is moving around, not X and Y. That is important. Z, X in Unity. Y is up. Y is here. Okay. So and is moving around. Meanwhile, here is the terrain, which one we actually will be using. A terrain we have a alpha map, and alpha map is about all the layers we painted, and alpha map starts at 0, 0 here, and it does has a certain size. The certain size we can find here, and this pretty much is text-based texture resolution is 124 124. I'm pretty much sure one of them numbers. So coming back to this our dude. So when the dude is actually standing somewhere, we need to transfer that. If I stand 50-50, yes, because the terrain is 100 by 100. If the guy stands 50-50, that means it stands in the middle of that image of alpha, which one should be a half of 1024, and that is 512. Yay! So first math answered correctly. Yay! So how we do this one? So inside the script. So what we need to understand first of all, we keep this one. So we need to understand that the terrain is black and green is alpha map. First of all, 50 bits. Z, this direction. X, this direction of terrain. In alpha map, we have X. Everything so far is good, and we have Y. So here is where some people getting confused, are writing code, and I've been in that position. And if you haven't been over there, you haven't coded yet a lot, because believe me, you will remember this my words. It will your code won't be working for some reason, and you will be pulling your hairs out from your head, and later on, a few days later, when you calm down and you look it back in the code, and you will remember I mentioned it about don't get it mixed up between these two. Yes, Y will be equal Z, and Z will be equal Y in the alpha map. Maybe because you listen now, maybe you won't be in that problem, but and you'll be very lucky. But believe me, I know it's definitely someone is listening now, and they definitely know what I'm talking about. Cool. So let's carry on. Another thing is we have 1024. We'll assume that number was correct of the alpha map, and we have one. Whoa, different color, and we have 100 by 100 as well. So we don't need to write both sides. It's a squares. So we're working with squares. So we need to take unit numbers, and we need to transfer to that one. And let's start creating the function. Which one can do this one? So the function will be private. Last time I done a bit differently, and I'm start thinking about returning it. Nah, we'll do the same way. I was thinking about how I can improve from the last previous my version, because I thought about function can return this one and I'll use, but later on I found that returning doesn't help me. I need to do more math inside this function and just save outside. As I said, placeholder of a memory, and to reuse another function. So cool, let's go back. So this function won't be returning anything. Who can guess it? And we just do what we do is we will convert position to alpha map. Correct. Convert positions to alpha map. Let's don't get it. So what we need to do for this function, we need to actually take. Are we recording now? Okay. For this function, we need to definitely take Vector3, and we call position. So we take this one, and we do some crazy magic here. So first of all, we will be required few placeholders, and we're putting here. So the placeholders I need is you know what? I'll grab one of them. They wanted to overwhelm you guys. Okay, so terrain position. So what we need to do first, we need to calculate a terrain position. So terrain position is equal to pos minus terrain. Do I doing correct? I start thinking. Okay, minus terrain dot transform. Dot position. So here, this will be terrain on which NPC is standing in. This is position which on where he is standing in the 3D space. So let's go back. So at the moment is on the first he is on the first terrain. Which one is here? Yes. So if you go left, if he goes left, right, if we go a bit here, if he goes here, if you can see, his position is 0 0 0 0, almost. But what's happened if he goes into second terrain? And take this one, we go here, we maybe zoom in, we should see some terrain. Okay, that's way more than I expected. So about here. Yeah, oh yeah, well, I can see just here. It's about here. So if you select this one, you see is in this corner, and it should be again 0 0 to get to alpha map, but it isn't. If we select our dude, it's a 100 and Z2. So the thing is, what doesn't matter where he stands in the map, we take his position and we take terrain position. We subtract all from each other, and that will transfer the terrain together with the dude into the 0, 0 locations. So it doesn't matter from where in the map the dude and terrain is. By subtracting from each other, we'll take from its original location and we'll transfer it in the corner where the bottom left corner from our view now will be becoming 0, 0. If it makes sense, I hope so. It makes sense. I take a lot of visualizations now to explain it. So that's as one of the key points. We want this corner 0, this corner of terrain 0 match alpha map 0. Otherwise, our map will be taking a big, massive algorithm to calculate. Maybe I don't know how it's even possible, but yeah, I think it's possible somehow to do everything. But easiest way just subtract each other. So we'll get the where NPC is on terrain from taking terrain's location and NPC. We subtract from each other here, and we get where on terrain he is. And that doesn't matter where the NPC is never become more than 100. Because if it's more than 100, he goes into another terrain and subtractions happens again, and it will be from 101, it becomes just 1. And so on and so on. So that's what's happening here. Okay, what's next in our list? We need to calculate map pause. Map pause. Okay, we don't have map pause yet. Map pause. So if you don't know, you can actually say private whatever and variable type, and you can put whatever how many you want just by putting commas. So it saves like this. What I just done here is actually same as I would be doing like that. Like this. Totally same. What I love to do is if they are related to each other and you're using the same class, or they are actually, you know, let's say you're doing, you need to, I don't know, paint a box in different colors, and you want to create the colors as a like variables. So you're saying color 1, color 2, color 3. So instead of creating each line for that one, you just say color and color 1, 2, 3 separated by commas. So if I have terrain map, I have now map pause, terrain pause, I have like maybe alpha pause, etc, etc. I can put everything in one line because they are really related. Not because I'm saving lines, it's the same way to saving lines and it's more readable, but because they are related, why not just put in the same line as the same type of variable? So map pause. Map pause, I use a Vector3, but it's only percentages. So if we go back to our drawings, if the where's my mouse gone? Okay, if the dude is standing here, yeah, at let's put black boy at coordination of 50, 50. Yes, that is exactly half of terrain in Unity. Not alpha map, in terrain, because if you're following, it's black. That means 50%. So 50% of X and 50% of Z. Not Y, Z. So what we need to do, we need to calculate these percentages. And if someone already guessed it, we will be using the same percentages to multiply and find where in the alpha map he is. If it's 50%, makes 512 in alpha map, and so on. So if someone guessed it already, well done. Carry on that one. Yeah, so map pause. Map pause is Vector3 which one holds the float. And if someone knows about percentages, you should already know that. Where is my mouse gone again? So 50% is 0.5. 1 is equal 100, and 0.1 is equal 10%. And the last example is, if someone got bored, is how much it is. If someone guesses it's 15%, 0.6, you're wrong. It is 1%, 0.56. Ta-da! I tricked you because it's a 0. So that's what calculations will do. And to do that one, you take his position and divide by terrain height. So because it's 100, it's easy to calculate, but normally what you do is you're taking current position and divide it by max position. That works for everything: rotations, positioning, distancing. If you want to get percentages, you take current number and you divide by maximum, and you get percentages in 0.5 or whatever, wherever 0.5 or whatever percentage it is. Not 50, but like this. If you wanna get like 50, then add multiplication by 100. If you actually want to do, but I would cast this one into integer, so I get rid of all the decimal points, because in this case you can get like 49%, 0.567, and blah 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 non-stop, because how many float points are, it will be that answer. If you want to print UI how many percentage you've done of your game, and you're getting this bloody long variable names, yeah, it requires another lesson to actually explain it, but yeah. So this is a core thing: current position divided by max position. Max position is size of the terrain. The current position is where the NPC are. So when we cover this theory, let's do it. So mpos is equal to new vector3, and we start magic here. So x will be the position with we actually passing. So oh no, we took the position. Oh, my OCD was kicking. What the hell I'm talking? So we took the position and we subtract from terrain position. So we get terrain, the position on terrain, which one is actually from 0 to 100 and no more. So whatever our NPC is and wherever terrain is, by subtracting, we're moving back. I'm repeating myself, I know, but yeah, it's better to cover again. So we're taking terrain pos dot x. So it's our current location in terrain divided by terrain dot terrain data dot size dot x. So whatever terrain size is. Now we no need y, it's 0, and z. Z will be again terrain pos dot z divided by terrain dot terrain data dot size dot. Aha! If someone guessed why. It's good you listen you listening me, but it's not this location where we should not mix up. Terrain itself it's not splash map, it's not alpha map, it's not detail map, and other images. It's actually 3D object. Terrain can actually have a size y as well. So what we're looking for is x and z. So we're looking from top view, how much is here and how much is here. We're not looking how much you are up. At the moment, by the way, it's flat. And as I mentioned before, one of my colleagues is actually doing sides. So carry on with that one. So when we done calculation, current position divided by position, we have this percentages. Now what we need to do is actually to take this percentages and calculate the same point, the red point, the pixel where he is on the alpha map. So close that one. Let's do this one. And for that one we'll be using another variable, and this one will be map position. Where we have this one? Aha! This is actually not a variable for placeholder. It's unfortunately it's not. It's not. It's for some reason I like this one to have a separate. It's a vector2 int, and we're saying a. Oh yeah, so we already have here. So this is a variable where we'll hold the pixel ID in the vector2 x and y in the splash map. So we already have. So what we're doing here is in this function where we got percentages, we calculate percentages. We're saying okay, a map pos dot x is equal to. We want to. Okay, I'll come to this one later. So we want to map position when we calculate dot x. So the percentages we want to multiply. So in our case, if it's 50%, so 0.5 multiply by terrain data dot alpha map width, and we get error. So 0.5 we multiply by terrain width, which one is 1024. We will multiply by 0.5, which one is half. We get we getting a 512. I know there is an error, but I wanted to debug with you guys so we get a bit more understanding. So if I hover the mouse, it's saying we cannot implicitly convert type float to int. This variable is vector2 int. It takes only integers. And because we're doing multiplication from floats, this answer is a float. And that doesn't, how to say, that actually doesn't do a good job. So what we're doing is we can actually cast, I believe it's called cast. So all these calculations we put in a bracket, and in the front we put another bracket, and we say the type of a variable we want this brackets to cast in. So whatever in this brackets we get, we want to convert to int. If I don't put into brackets, we will get actually we don't. But what we do now, we instead of converting the answer in integer, we're converting the first item, and actually I know the answer. The answer will be always 0 now here. I will explain in a second why. So converting to the int. What the computer does. Let's say we have 1 point. Well, in our case, 512.46. Let's say. Converting to the integer, the computer, what it does, it just deletes all the decimal points. It does not round up, or what's called round up, round down. It's not getting to the nearest integer. It doesn't do. If we get 512.99 and we convert this float into the integer, what the computer does, it just makes 512. So in our case, if we convert 0.5, which one is 50%, to the integer, we'll get 0. So in our case, if we delete this one, we're not getting the issue because this is a float and we're converting to integer. But because it's a 0.5, it becomes 0. And 0 multiplied by this one, it's nothing. That's why we want to do multiplication first and only the answer to convert to this one. Okay, you can say, okay, we look, but we are losing at least 1 pixel. What's called not currency, accuracy. That's the one. So we're losing at least 1 pixel accuracy because we're not rounding up. If it's 512.99, it should be 513 because it's much closer pixel than 512. And you are deadly correct. So one of the easiest way to do is, doesn't matter what number you have, before you converting to the integer, add 0.5 float. So if you are above 0.5, by adding another 0.5 you get 13.0, and converting to integer you get 13. If you are 99, by adding 0.5 you get 13.49, converting to integer makes 13. If you are, let's say, 0.2, adding 0.5 makes 512.7. Converting to integer leaves 12. So by adding half, you rounding this after conversion, you actually done rounding up. If it's over 0.5, you're getting 13. If it's 49, let's say it's 49. Mathematically, if you need to round up, it goes down. So you add 0.5, you get 12.99. You convert to integer and compiler just delete the decimal point and you get 12. Which one is correct answer? 512.49 is 512. 51, mathematically, if you're rounding up, it should be 513. So 500, by adding half, you're getting 113.01. You convert to integer, it deletes the decimal point. Yes, it's correct, 512. You just round up by adding just half. So before we convert, we've done multiplication, and then we just add 0.5 float just for rounding up. And now we need to do same with position Y. So, and here was the beauty, don't forget, it's Z and alpha height. Okay, let's have a look. We'll want to look in my notes. Yes, we converted, and finito. Done. Now we need to create the function which actually paints. Which one actually paints the terrain? Okay, so it will be private. It won't return anything, and we want to paint texture, and when we want to paint texture, we want to get terrain paint request. So TPR. So we want to get the request and we want to paint it. So the first straight away, the paint request, as we created a class at the bottom, has these variables. We have point, position, and all of this. So when we receive from NPC request in a bucket, we check the bucket. It has something inside. Let's paint it. So TPR is passed to this painter request. And what we do is saying, okay, first of all, we need to convert. So let's convert position to alpha map. And what position? We're saying TPR dot position. Nice, straight away. So we pass this position into the function, it converts and saves as a alpha map position. We're not returning, we could return here vector2. I can't remember why I did it this way, but I think it's something messing around in the code later, so it's just done this way, and I'll just reuse it, this one. So what we need to understand here now, each pixel where in alpha map we have floats. Okay, so each pixel can be accessed by x, y, so x and y, and that is correct. So maybe we'll delete this one. No, okay, leave it. So let's take one of here. Let's take one of the pixels. Here is a pixel, and I will draw wrong color. So it's an alpha pixel. It's not a black one. It's not in unit. It's in an alpha map. So we have a pixel. The pixel holds 3 variables. It does have its x, y, yes. No, sorry. The pixel holds the float number, how much it's painted off a certain layer. So the grass at the moment is painted at 100%, and the dirt is painted at 0 at that pixel. So how you can access this one? So you have alpha map of all the pixels, and it is 3-dimensional array. Which one has x, y, and the most important, layer ID. By giving all this free numbers, we can actually access. Sorry, I wanted to correct this one. So we can actually access. D. We can actually nice. So we can actually access the number of how much that layer is painted at that pixel. So in our case, all the pixels in this map would be painted at 100 grass and 0 of dirt. So if we coming back here, and if we can just grab our dude, which one is somewhere very away. Okay, I want to get back 50-50 somewhere. Nice. Let's get back in your ring. So how to know which one layer is which one, by the way. I'm not have worked on the layers at the moment. I have a bit issues with the layers. They are not sorted, because you can actually, if you go here, you can actually see it's a bit like mess. It was more like trial paint around and so on. But we have layer 0. This one is layer 0, and we have layer 1, which one is second. And now when I painted that location, each pixel in the splash map become 0 grass, 100 dirt in that certain pixels, which one I just painted. Or we can actually take this one, and we're saying, okay, we don't want it to paint that much strength. We want to paint 0.5, 50%. So we have like this. Of course, where is overlapping, we have more, and if I move, it becomes like even more. So you get the idea. So then I painted, now I have 50% of grass and 50%. Oh, sorry. 50% of the dirt, and so on, and that's how they start overlapping it. I wasn't sure in the beginning. In the beginning when is a base color actually decreasing, or it just other layers on the top is actually painted. But I done some debug logging and I print the values of a base material, and actually the values goes down. Even though from a camera it doesn't look like that one, it looks like a base is always 100. It's just painting on the top other colors. I'm not sure, but I checked some debugging, and this is results I received. So I'm assuming this is how it does. So 50%, and we have some overlapping. Then we have like, I don't know, it's getting like 40%, and it's getting like 60% in a certain locations, like you see here. You can see here is like overlapping, so it's more than that one, and so on. So this is what we want to do. So where are you? Okay, let's paint you back. So this is what we want to do. We want to pass X, Y, and layer ID. And when we pass all these three numbers, we get a number like 0.5 of dirt. And if we pass like dirt is layer 1. One more time. Layer 0, layer 1, layer 2, layer 3, layer 4, layer 5. If I wanted to find out wherever this NPC is standing, how much we have layer 1, 0, 1, 2, 3, 4. Like, let's say this one. And I'll need to put location X and Y in the splash map, which one we converted. And I need to put layer 4. And then this alpha map will return some value. In our case would be 0, because there's nothing painted here. I hope so this makes sense. It's going to make more sense when we start actually typing in. So stick with me, and we will be doing this one. So we actually not have created that one. So let's give it a name, and that will be a private, and it will be float, because it will hold a value of that one, and it's 3-dimensional float. So we need to access by X, Y, and ID of the layer. So that in C# you just do commas, and you get create a that's how you create a 3-dimensional array in C#. Just putting commas, C# knows that you need 3 values. So going forward, we now need, because we now we need to link it. So a map is equal to terrain, of course, dot terrain terrain data dot get alpha maps. And when you start brackets, you can see what we need. Sometimes we have arrows here, so you have the same function, but it can take a different parameters. I hope I will cover this one in a future tutorials. That called is overhead? No, not overlap. Overload. Yes, overload functions. Which one is the same function, but will takes different parameters, and parameters like a signature. So it's the same naming, but it's different calling. So let's go this one. So get alpha. So what do we need? Int X, int Y, width, and height. So far we know it's a map pos alpha map position dot x, alpha map position dot y. So we know where in the alpha map it's our NPC stands for, and this is a width and height. How many pixels you want to read? You can read more than 1 pixel. So this is what it gives. So far I was trying to look ahead, turn ahead around how to actually to do the circle, but I think we in the fading position I need to achieve this one because it's not really achieving in this one. But it's easier to take all square and then just paint only circle afterwards, then just call this one every pixel you want to actually get out in a certain what's called figure. So some happen that we actually have this number. So we have tpr dot paint size and tpr paint size. So we have what we want, and because it's square we just take one number twice. But it's only the main core we want to paint. Don't forget we want to paint and a fading zone. So what we need to do actually tpr plus tpr fade size. So we want to read a main area we want to paint, and we want to read from alpha map fade size as well. So we're taking a bit larger square to have a space with the values to when we read them to actually manipulate, adjust, and have nice fading away from that our NPC. Okay, moving forward. Moving forward. Okay. Oh yeah. Middle pixel. I'll leave this note for the next lesson. Mid pixel calculation. Wow, oh jeez, guys, what the hell? I said calculation. Mid pixel calculation, and what else? Fade values. We don't want that one. We just wanna we just wanted to do a nice painting stuff. So what we do now is we do for loop, nested for loop. So for int a is equals 0, as long as we are actually not. Oh yeah, a small thing. If you think this way, Jesus Christ, we have quite a lot here. Do I have a space somewhere to draw? Yeah, we have. So this is a main area I want to paint. Which one is, let's say, square of 5. And I wanted to paint another square 5. So by adding 5 fading zone, I need to actually add twice, because I need the same fade zone in all areas. And if you now see, yeah, if you now see what's happening is our 5 plus 5 doesn't make sense. We need to 5 plus 5 plus 5. In our code, if we're coming back, if paint size is 5 and fade size is 5, we actually have fade size we have in both sides. So we need to multiply by 2. So 5 plus 5 twice, if we go back to drawing, so 5 is middle one, and fade plus fade in both sides, in left, and we need to do the same here, left and right, normal brackets. So yeah, so now we run, so we need to find out how many. So let's summarize. So a is equal to 0 as long as a is less than tpr dot paint size plus tpr dot fade size multiplied by 2. So how many squares we have? Each time increase by 1. What we will be doing will be each a, it's let's say a it's x, or a it's y. So each time we increase y, we need to run x. Increase y, run x. Increase y, run x. So that's why we have a nested for loop. So for int b is equal 0, as long as b is less than tpr, same pane size plus brackets. Oh my gosh, I can just copy paste. Yeah, and we want to be plus plus. So want to loop. So we want to loop all the area we just read it. So what have we actually done it? So we have this dude in the middle of a map. We know it's a 50%. We calculated which one center pixel is 512. But what we want to read is actually 15 by 15 square area. And now what we're doing is we're actually looping from each of them. Looping from each the pixel we read it. We check what value you have in each layer, and we decrease or increase depending of the paint strength. Yeah, one of the key points what we want to do is actually to check is the pixel is in the fading zone or is in main zone. At the moment it's not fading off. I'll do either way. I was thinking about this one to not overcomplicate. So what at the moment we'll do is actually to check the pixel here, and we do a full 100% of paint strength, and if it's in Y, we do a half paint strength, so smaller amount. So what we need to do here, first of all, where is my mouse? It's gone. Yep. Okay. So what do we check? If A is less than, oh Jesus Christ. Okay, let's me think. If A is less than fade size, TPR dot fade size, or A is greater than TPR dot fade size, or maybe B is less than TPR dot fade size, or maybe B is greater than TPR dot paint size. Okay, we haven't done this one here as well. TPR dot paint size plus fade size. So TPR paint size, TPR paint size plus TPR dot fade size. If we do this one, we do something here, and else we'll do something else. Okay, so what I've done is actually to check if by asking if so A is this way. Yes, this is A. So we asking if A is less than fade size, so is it less than 5, so somewhere here, or it's greater than fade size plus paint size, so this area. And by doing this one, we still leaving with this area and this area. So that's what we will do with. That's why we do with B same. So asking maybe it's here or here. Yeah, and it's not overlapping because actually what it does is in this area, if it hits true, it's not checking B anymore because how the compiler works, because in or here, it's if it hits here true, it won't be checking other ones because it's true and there's no need to work this one. So if conditions, you always need to do the easiest less taking performance condition forward. Let's say you have AND condition. If one of them is false, all the conditional, if conditional, will be false. So what you're doing is you're putting the first one, much easier one, like a boolean, before you're doing, or second one is like a function which returns the boolean. So what you're doing is you put the boolean first, and if the compiler finds the first boolean is false, it's never run the second one. It won't check the second one because it's AND condition. They both must be true. Why compiler need to check a second one if it fails on the first one? So that's why in if conditions is really smart to put easiest ones conditional checking actions first, and the most easiest one is boolean, true or false, less, more, equal, not equal, that ones. Okay, cool. A bit bored up. So what do we have here? So here what we do is oh yeah, changes, paint. Do we have a paint? We have painter strength, paint strength. Yeah, we have. So if it's here, so we're saying okay. Okay. That's interesting. Huh. Yeah, because I have another code which one is a bit more complicated. I wanted to try do easiest way. So let's say we want private, and we want to float and paint strength adjustment paint strength adjustment. So if the pixel is in the fade zone, we want to say paint strength adjustment is equal only half of terrain paint request dot paint strength divided by 2 f. Why not? So in this case, painter strength adjustment is only half what we're asking. Otherwise, paint strength adjustment is equal to TPR and paint strength. We need to set back to this one because if we got in the fade zone, we need to set it back if the next pixel is not in the fade zone, so it's keep jumping between these two. We could save both of them, which one I've done in my code. We just done once before we gone in loop, so saving some performance. But at the moment, just for the sake of the easiest way, we just check if it's in the red zone or is a main zone, and we have a paint strength adjustment, half or full. And when we know the paint adjustment, now we need to check if alpha map, yes, which one we read it, yeah. If alpha map at A, B, which one we're looping each pixel, and layer 0, so the grass layer, is greater than 0, so that's mean it's still not disabled. 0 means the grass is gone, the dirt is fully 100%. So if the grass is still greater than 0, then 0, sorry, what we do, we're saying, okay, alpha map at a b pixel layer grass will be equal to minus equal to painter set adjustment. So we subtract that painter strength. It will be, if it's in fade zone, it will be half of a normal strength. If it's in a main zone, it will be full subtraction. Meanwhile, when we're subtracting the same time a map, the same time at pixel, the same pixel in alpha map, the layer 1, which one is dirt, we want to increase that painter strength adjustment. So we want to increase the dirt. That's it. After all this for loop, when we read that location here, read the values of the terrain map, we read them, we adjusted them here. Now we need to push back into the terrain, and that's really easy. Terrain dot terrain data dot set alpha maps, and we know the alpha map position of X, where our NPC stands. A map ma pos dot Y, and now we need to pass a map. If you see here, as I mentioned before, it get bold what variable type you need to return, and it's a float, and it's 3D float, 3-dimensional float. And well, that's happened when we have 3-dimensional AD, and it's called a map, and we return it. This line, 72nd line, is the most expensive one. This is a reason why you want to do only once per file you want to do only once per frame, and you want to do in smaller scales. So you don't want to do whole map in one go. 700 by 700 will be like, you know, 7 by 7 terrains, and each of them has an NPC in them. So you don't want to do all of them in one go. You don't want to do whole map. You don't want to do multiple maps, because you know you have a small squares. You have NPC here, you have NPC here, and you have NPC here. So you don't want to do them. You don't want to do all the map. You don't want to do 3 different squares the same frame, because that builds up. And believe me, after 4 of them, after 4 NPCs, I drop down below the 60 FPS. Even though my wooden computer is not most performance, you know, device. But still, it's really adding up. So this is a line where I put, you know, like explanation. So be careful of calling this one. So this will be in a perfect end of this tutorial. We try to put this one into another thread. We'll be using Unity job functionality. We're getting really good, better and better with each release of Unity with the job system. Normally to use threads is really difficult and really risky to crash your system, or even actually to get to even lose more performance, lower FPSs. So the jobs, Unity, they actually creating an environment where coders can actually use this one, and they maintain all the difficulties behind the scenes. So I'll dig in that one in the future videos coming up. Will be great. I hope so. I hope you guys enjoy it. So that's all with here, and we have a really small one more script to do. And that will be really quick one. I know it's getting long. If you're still watching it, well, if you're still watching, that's great. So terrain interactor, do I have no? Create new terrain interactor. terrain interactor. Yeah, so this is a script we'll be adding to any object which one actually interacts with the terrain. So at the moment, interactions only is to paint it or interact with the grass, but later on it will be filling the holes because we'll have some workers and we have some stones and other things, and you want to actually you want to clear the environment from all other obstacles to build some buildings, and taking it back to this ages because if you saw this, by the way, dude, you can actually assume it won't be 2020, you know what I mean, and this will be a bit older days. I don't want to spoil it yet. I hope so. I'll prepare later on some nice video about all the bits. Bits and bobs, as you say. So what I'm trying to say, what terrain interactor is, the script will be script at the moment do only these two things. Later on it will be expanded even to more functionality. That's why it's called terrain interactor. So if we go back to this one, painter interactor, we can remove control, leave it. So let's add terrain interactor. Yeah, back to terrain painter script. I don't know why it's added here, by the way. It should be here. So terrain interactor is added to our dude. And going back to script. Coming back to script, we need to open it, of course. No. What's happened to you? He don't likes me. Oh, okay. Got it. Let's open it somewhere else on the screen. I haven't seen it yet. So, hate these lines. It will be actually quick. So, each NPC, any game object, which one will be interacting with terrain, they need to have a reference to only one script, which one has a bucket and all functionality. It will be only one present of that script, and we need to actually have reference to that one. We have terrain interactor script multiple instances to each object which one need to interact, but terrain painter will be only one, and we need to get reference to it. First of all, we need to create a variable to hold that reference. So terrain. Oh, sorry. Terrain painter. I don't know. I call TP. Terrain painter. And you see, I don't say it's new, and I'm not creating new one. In a start, when the game starts, I say TP is equal to game object dot find game object with tag, not objects. It's an array. It will return all the objects with the tag. I want to find only one game object with the tag, and we need to give a tag. So the tag will be terrain painter. Terrain painter. I will be predicting that this tag wasn't created, so I'll give you later. So game object, find game object with the tag terrain painter. So let's go back to the Unity. So in my environment where I have terrains, let's remove this one. I'm adding this terrain painter script, and here's the tag. I'll pretend it was untagged. So what you need to do is you need to add the tag. You press this button, and you add the tag. You need to name it, and it's a case-sensitive naming. So you need to pass the same tag name. Now, when you've done this one, after you've done this one, what most times I forgot as well to do, you create the tag, but you never add it to the object. So you need to go back to the object by selecting it, and you see it's still untagged, even though you just created a new one from here. what you need to do is actually to select the terrain painter. So you give a tag name at terrain painter. It's for this one. It does has a script. Going back to this one, it gives the error. The error is really simple. You need a type of object, terrain painter. What you done here, you actually find game object. Game object has transform, has the script, has physics, has other things, and so on and so on. Has naming and other lot of components. That's one component, and you can add even more if you want. Yeah. So, what you need to do is, in a script, then you find the game object. You need to say, okay, I found a game object with a tag. Now, get a component. And component, which one I want from you is terrain painter. That's one. And its function. Don't forget to put function. That's it. Now, here we find a game object, and from that game object we getting this script, and we're saving as TP for later use in the script. If you look here, from all the hierarchy we find this game object with this tag, and from this game object we're getting this script, and all NPCs in the map we will be getting reference to the same script. So that's how this works. I hope so. It's not. I'm not going too much in detail. So now we need some public variables. I promise we are really close to finish. Float a trigger. Trigger distance. So how far the NPC keep walking? Yes, from the last position to actually to trigger to paint a new area, because we painting as you remember, we're painting 5 by 5 by 5, so 15 pixels in an alpha map. So how much distance NPC must to walk, yeah, to request new square to paint in? So something like this, and it will be keep walking, and it's like painting like the small squares. Yeah. So let's going back, and trigger distance I found so far today for today's video. Let's put 0.4 float, so 40 centimeters. We walk in. We can actually, it's a public, so we can actually adjust whatever we want. So as we mentioned before, public int paint size of this dude is 5, and we want a public int fade size of this dude as well. We mentioned about it's 5. We can adjust later on. And the public float paint strength is 0.05. For this video purpose, I want to increase like 0.1. Let's do this way. So what I want to do is actually to increase the strength, because I wanted to visualize even better. Later on, when we do this one, we even increase to half, 50%, because we want to see one square painted, and we work with fading zones, and you will see where's the problem in the end of this video, so we can actually address inside the next video how to improve this fading things and so on. So one more thing what we need to do is a private and it's a Vector3, and it's a last position. So last position where we actually doing it. So first of all, when we get a reference to our terrain painter, now we want to say last position is your starting position. So transform dot position transform dot position. That's it. Yeah, that's it. Every frame, we can start checking. One of the great things is, but we no need to do every frame. We can actually, what we can do actually, it's actually to use, maybe it will be overcomplicated, but every single time when we get a reference, we can actually have another bucket of all interactors, and Terrain Painter can actually ask only one, how to say, ask only one of the objects, game objects, interactors, how far they went. You know, because that saves quite a lot here. Because why we need to actually to check 20 of them every frame. Okay, you can say, okay, let's do every half a second, because the people, if we said the trigger distance is a 40 centimeters, yes, so we say, okay, let's check every half a second, or at least second, because we know the human walking speed, and he can actually just go 40 centimeters in 1 second, assuming, yeah, let's assume this. So we can approach this one, but we still will we'll still bang the head in the same problem. All 200 people in our city will be walking the same speed, will be hitting the same frame trigger. They will be triggering with the same frame, because all the same, we have the same speed, and we keep walking, and we just hit the same speed. I think when we do another thread, we can actually pass this this checking thing into another what's called routine. You know, just keep checking your distance, and if you actually went this trigger distance, just yell back, I need to paint. This is a location. So something like that. Cool stuff. Okay, at this point, at this first video, we do this one. Vector3 Dot Distance. This will return the distance between 2 points in Vector3. So we have transform dot position. So our current position, comma, and now we want to actually last position. So where you been last time. And now if this distance is greater than trigger distance, we want to do something. So that means our NPC walked, in our case, 40 centimeter. So if he walks 40 centimeter, we have reference to Terrain Painter. We can say, okay, add terrain request. We asking you to paint that location. Where? Well, transform dot positions here, comma. I can see we put positions. Now we have in paint size, fade size, and paint strength. So because we have all these ones, we can say paint size. Yep. And now we have fade size, and we have paint strength. Super. Cool. And oh yeah, one thing don't forget. So because the NPC walked 40 centimeters from that location, we call the trigger to paint that location. Now we need to remember this. Last position is equal to the current position, where we actually just painted. And by doing this, voila, that I think we done. Just small test now. Why not to maximize this one? If it works in the first go, it's good. Most times it doesn't. Okay, we have a null reference. I know what is null reference. Yeah, I forgot this. So we need to. It was in to-do list. So terrain don't have what terrain in NPC stands. So for the moment, we just give the first terrain its stance, but it should be a function which one returns terrain where it's standing on. So it should return. But now we just get the first one. So terrains, you get the first one, and easy peasy. And because it's a reason why script has here for array, this parent will take all the kids. So all this terrains is actually our terrains which one NPC can walk on. So it's instead of hey kitten. So instead of we dragging in all building terrain, we just grab all the kids. But that's will be for a future. Yeah. We have 1,200 road blockers. I'll do a later video about that one maybe. We'll see how it goes. Okay, we still have a null reference, and we're not painting it. So why we have a null reference? Are we missing something? What are you missing? Paint, terrain. Let's have a look. Terrain painter. Okay, I'm messing around with spelling, yes? Did I? Terrain painter. Okay, terrain painter. Huh? Oh, yeah. Silly me. And, yep. Save. Okay. Oh, what's up? My cat just came in. I think he is hungry. Don't press the buttons, no. Okay, so let's zoom in. But yeah, and it's not painting. Is it? So let's have a look. We have paint strength. Let's put 1. And game object with a terrain painter and terrain painter. Last position and book and 4. So let's have a look this one. Oh, paint. We never requested. So if we have in a bucket more items than 1, we're removing, but we never call paint texture first. So paint texture with terrain request queue. Take the first one. So we need to paint the texture with the first request in the bucket, and then we remove the first in the bucket if we have anything in that bucket. Save. Ctrl-Shift-B for a build, and let's have a look. I can see the CPU going like, oh, okay, 80 frames, and voila. So yeah, I've set like painting like 1 N is like, yeah, it's like, and I can see the sizes way bigger, but you get idea. If you don't want to so squarey, it's 2 things. First of all, when we got more performance, we can actually, and when we complete the code, we can actually increase the resolution of alpha map, so it won't be so squarey. That's one thing. Another thing is you can actually increase how often you want to trigger the paint, so it won't leave some massive gaps and it's going. Another thing is, if you just realize it, by the way, even I start the game, what you painted will stay on a terrain, so be aware of that one. In the game now, because if you restart the game, it deletes. But in this way, when you're changing alpha map, it's not returning back. You know, so be aware of that one. Okay. Yeah, one more bit. If we want to just change back to like, and Oh, sizes, yeah. I can do sizes less. Shit. Yeah, the size is like ridiculous big. And that one looks like not. So maybe 3 by fade size about 3, something like that. And oh, I can increase the speed as well, but yes, the trigger. Oh yeah, triggers in the doesn't matter the speed. So yeah, you see, it's like leaving nice trail, and more often your city people will be walking same like location. It will start build the your city. When you build your city, your NPCs, like, okay, you have like woodcutter, and you have like gathering what's called gathering berries. It goes left and it goes back with all the things in the hand and goodies, and it will keep leading the trail. And this trail in united nav mesh will cost less to walk, so it will push all the NPCs to start walking with a certain path. So of course, wanted to make 1 and 2, and it looks like that. You wanted to make like 10 times goes, and it's like making like path. You can choose better layers as well, and of course you need to play with the grass first. So will be next videos. This is the first time. I hope so, guys. You like it. Any comments? I appreciate. Yeah, thanks for your time. It was longer than I expected. I hope it's covered the first part. I try to keep it this video slower, like shorter. So, thanks, and see you soon for our next video. And I'll go